My name's John Arthington. I'm an animal scientist with a focus on beef cattle nutrition and management. It's my responsibility today, or my turn today, to give you an overview of our program here at the Range Cattle Research and Education Center and tell you a little bit about some of the current work that we're involved in. Over the last several years, our program has had a direct focus or emphasis on the mineral nutrition of grazing beef cattle. And as many of you know, that management system relies on the free choice intake of salt-based mineral supplements. So unlike animals that are reared in confinement that typically have access to a total mixed ration or formulated feed stuff, where you can add minerals and vitamins at the levels of intake that's required for that animal or stage of production. It's different for grazing animals, where we may provide these free choice supplements with the anticipation that the animal will consume an adequate amount to meet their requirements or needs. A lot of this is based on a concept or a theory which is largely untrue, that grazing ruminants or grazing animals will consume the mineral at their requirement, and so if they're not consuming enough, they must not need it, or if they're consuming more than our targeted amount, they must need it. And neither of those are true. Cattle only have a nutritional requirement to consume salt at the level of their need. So as long as we have adequate amounts of salt available, cattle will generally never be deficient in sodium, because they will consume salt at or many times far above their requirement. The same is not true for other elements like copper and selenium and zinc, which are the most limiting for grazing beef cattle in Florida and in reality in many parts of the Southeast. And so it's this free choice salt-based supplementation system that's the most common for providing minerals to our cattle. So here's some data that was collected here at the Range Cattle Station many years ago, and it's something that I show quite a bit to illustrate the annual seasonal variation in free choice mineral intake. In the Southeast, and particularly down here in Florida, it's not uncommon for our salt-based minerals to be formulated for a low intake, about 2 ounces a day, right around 60 grams a day. We'll move further to the north, and in the Midwest, we'll see intakes formulated for 4 to as high as generally 4 to up to 6 ounces a day, so much higher. So what we did in this situation is over 3 consecutive years, we provided 2 ounces of mineral per cow per day, provided weekly, and then we measured how much they ate or didn't eat. And it's represented here as weekly refusals. And what you'll see is during the winter months, they refuse quite a bit, meaning they do not eat the 2 ounces of targeted mineral every day. And then during the summer months, when it's wetter, they start to crave salt more, and they always eat that. And so that's generally the system that we see in the Southeast for salt-based minerals, is that during the wetter times of the year, when they crave salt, they overeat, and during the drier times of the year, when they don't have a salt craving, they undereat their mineral. There's many other things that can impact it, such as intake variability within individuals in the herd. There's spoilage and leaching, which I'm going to show you at the end of this slide, and then the contribution to wildlife. What are the deer and the hogs consuming out of our mineral feeders that we intend for the cattle? Now, this is just an illustration of why is it important. In Florida, we will ship 500,000 feeder calves every year outside of the state that are weaned from our cows here in Florida. On the graph, what it shows is the decline in selenium status of our calves over that time. So at 150 days of age, we sampled these cattle for the first time, and then at 250 days of age, when they're being weaned and shipped out of the state. By the time they reach that age, those calves are selenium deficient. However, they are nursing cows that have access to a fully fortified selenium supplement. The problem is the calves are not eating enough of that salt-based supplement, and the milk that they consume from the cow is very low in selenium, not enough to supply their requirement. So the picture of these calves on the right is calves that were weaned from our cows here at the station. Healthy, growthy calves, nothing wrong with them, but they are selenium deficient. And then what happens is if they are shipped and transported and received in a stress-free environment or a low-stress environment, and they get onto a growing ration or supplement at that time, they'll revert back to normal conditions quickly. But if they don't have that situation and they're exposed to a high level of stress or maybe a pathogen load that was unexpected, it is a recipe for a problem. And this is very common across the Southeast. And so we have this idea that we could do something called limit creep feeding. And traditionally, creep feeding has been not a system that has been widely adopted among cattlemen for a good reason. Creep feeding results in the poorest efficiency of body weight gain that any phase of our beef production system could encounter. Generally, we would see gains at around 8 to 1 or 10 to 1, meaning 8 to 10 pounds of feed for every 1 pound of body weight gain. And that's when it is calculated correctly. A lot of times producers might look at creep feeding data that's calculated incorrectly. And that is taking the total body weight of the calf from the time you started creep feeding to weaning, divided into the amount of feed or creep feed that you purchased or the calf ate. And that's incorrect. Because if you didn't provide creep feed, the calf would still grow, but not as much, right? It would grow out on pasture with the cow. And so what you have to use or understand is what's called additive gain. How much more did they gain with the creep feed that they wouldn't have gained? And when you calculate that, it's a very poor body weight gain, and that's the reason why traditionally producers have not adopted creep feeding. Our system is different. We're looking at a limited creep feed where we're not targeting increased body weight gain, but rather a vehicle to deliver trace minerals to calves prior to weaning, so that we can wean calves with adequate trace mineral status, unlike what we have in our traditional system. And so this approach has looked at feeding about 1/4 kilogram of feed to the calves every day prior to weaning. Generally, we talk about 100 days prior to weaning. Most of our studies use 80 to 90 days. And here's some work that Dr. Felipe Moriel and I put together right at the end of his program here, where we looked at feeding this dry feed to calves in a limit creep situation that was either fortified with minerals, that's the circles, or not fortified with minerals. And look at the problem that we have. If you take and concentrate this feed with the minerals that we want to get in the calves don't like to eat it. It's some sort of palatability issue that calves are very sensitive to with highly mineral concentrated supplements. So it was a problem, something that we worked on trying to add different palatability agents like flavor enhancers, yeast, dehydrated alfalfa meal, these types of things that would help get the calves to eat it. And we continually ran into problems. And so somebody along that way introduced a concept to us called solubility of minerals. And what we had anticipated, or at least hypothesized, is that these calves appeared to have an aversion to the feed stuff that was concentrated in minerals. And so we thought, or at least hypothesized, that it was because of the metallic taste that was being presented in their mouth because of the highly soluble forms of copper, zinc, and manganese that we were providing. Now, we didn't have a way to test for taste or taste aversion in calves, but we wanted to look at what we call preferential intake. If you offer calves the exact same diet that's formulated with highly soluble minerals or highly insoluble minerals, do they prefer the intake of one or the other? There's a group of minerals that are available that are called hydroxychloride minerals that tend to be highly insoluble. And so we compared those to traditional inorganic minerals or organic alternatives. And we ran several studies in this area, but here's just one of them, where we took those supplements, those limit-fed creep supplements, identically formulated, but containing 3 different sources of copper, zinc, and manganese. And then we offered it to the calves for 4 hours a day in replicated pens, all we did was just look at what they chose to eat. And here are the results. The feedstuffs that were formulated with the hydroxychloride forms of copper, zinc, and manganese were almost exclusively selected over the other two when the calves were given a preference. This is intake represented by each of the individual options that they had. So in each of those days, those intakes sum to 100% of that intake. And you can see that between 70 and 90% of the preferential intake came from the formulations with the hydroxychloride options of copper, zinc, and manganese. So we moved into the next study, and we wanted to see if the same thing was true with salt-based minerals. So when we provide a free choice salt-based mineral to calves, would they also prefer to consume a mineral that contained the insoluble source or the soluble source of copper, zinc, and manganese? So we ran the same type of study in experiment 1. We looked at hydroxy, sulfate, and organic sources of copper, zinc, and manganese. And we looked at preferential intake represented as a percent of total intake over an 18-week period right prior to weaning, just before weaning. And that was done in 8 pastures containing approximately 20 cow-calf pairs per pasture. We did it in our system here at ONA, where we're able to look at differential intake among cows and calves through a cow exclusion area, and that's this creep area that you see here, or a calf exclusion area, and that's achieved by a feeding area that by height is above what the calves can reach. And then in stainless steel bowls, we offered them the exact same formulation, but offering 3 different sources of copper, zinc, and manganese, and then measured their intake weekly. We found quite similar results, although not quite as dramatic, with the concentrated feeds, in that the calves preferred to consume, given the choice, the salt-based mineral with the more insoluble forms of copper, zinc, and manganese. So I'm going to pass that and go on. So this weekly variation in preferential intake was interesting. It wasn't the first time that we looked at it. The year before, we tried the same approach, but we didn't do it in covered mineral feeders. And at the beginning of the study, we saw the separation in treatments, just like we saw here, where the calves did prefer the option, mineral option, with the insoluble forms of copper, zinc, and manganese. But then, on strange weeks, that preference would go away, and they would consume all 3 of them equally. And then a week or 2 later, it would go back, and they would consume the, or prefer to consume the insoluble source. So there was extreme amount of variation. And the student that was working with us at that time, she explained to me that after heavy rainfall events, the preference for the hydroxychloride minerals would go away. And then during weeks or that low rainfall events or dry weeks, they would prefer the hydroxychloride form. And so much to the point that after that mineral would be soaked from rainfall, we would even see a coloration of the water underneath. As some of you know, that some of these elements, like zinc, tends to be green in color, and copper tends to be blue in color. We'd have this bluish-green color in the water underneath the mineral feeders after these rainfall events. And so that student, Dr. Maria Silveira, and myself worked together to establish a benchtop leaching experiment to see how much mineral was lost from these types of rainfall events. So what we did is we simulated a 4-inch rainfall that was delivered over 3 equal events. So not 4 inches at one time, but 4 inches over 3 events delivered on Monday, Wednesday, and Friday. The water was pH adjusted to 5.6, which is typical of the pH of rainfall, and we simply poured the mineral or the water over the top of the mineral in a flask, a funnel, and then collected the leachate that came out in a flask. And then we looked at the change in copper, zinc, and manganese concentration of the leached and unleached product. And so here you can see how it was set up. Since the time of this first experiment, we've evaluated many different minerals, and it's quite a nice approach to look at leaching losses. But what we found was quite interesting, in that if you look at the percent loss of copper, zinc, and manganese, in this slide it's zinc and manganese, with a 4-inch rainfall. Now this is all 4 inches. This is the direct loss with 4 inches achieved. We're getting about 50+% of the zinc from zinc sulfate or organic zinc that is lost from the product after that 4-inch rainfall, with much less losses with the more insoluble forms from the hydroxychloride. If we look at copper, the same pattern is true. However, the total losses are much lower, but still the more insoluble form of hydroxycopper is less lost compared to the sulfate and organic. And so what we think is happening from that is when we see these large rainfall events, half of the metal is being lost from the mineral. And now the calves no longer have an aversion to that mineral because the metal's gone. And so we don't see the preferential differences in intake. But on the dry weeks where we don't have the leaching events, the metal's still there, and we do have that problem. And so one of the things we're trying to teach producers is the value of keeping mineral dry, and that producers may not be feeding to their cow herds what they think they have just bought, because it is undergoing these leaching events. So, just to conclude, the pre-weaned calves, they have a preference to consume salt-based minerals that contain less soluble forms of copper, zinc, and manganese, and that these less soluble forms of copper, zinc, and manganese are less vulnerable to leaching losses. And things such as organic copper, zinc, and manganese are highly soluble and certainly succumb to leaching. So what I'm going to do now is move into the next part of our presentation, and I'm going to introduce Juliana Ranches, who's a PhD student in our program, and she's going to talk to you about individual animal variation in free choice mineral intake. What we have done in this area has been fairly new, where we're using RFID technology to measure the frequency of visits to mineral feeders and how the different types of management systems will impact these this frequency of intake visit. When she's done, we will have an opportunity to take questions from both the presentation that I've just given you now and this information that Juliana has presented. So I'll turn it over to her.
Okay, so good morning. So today I'm here just to talk about some results that we have from our readers study. So I'll give a brief introduction because I guess Dr. Arthington covered very well what are the concerns when we are feeding salt-based mineral supplements to cattle. So mineral deficiencies are common for all cattle around the world, and almost all grazing cattle are deficient in sodium, thus salt-based supplements are required to have a better performance and health of grazing livestock. So in tropical and subtropical climates, where we have a large production of beef cattle, those animals are usually enrolled in a year-long grazing schedule, which means that the animal is going to be in pasture for an entire year. So on those systems, what producers do is just offer a salt-based free choice mineral to those animals. And so what happens when we do this kind of system is that we offer a mixture that is targeted for a specific amount of minerals, trying to offset any nutrient deficiencies that those animals could have. So the big problem with this kind of system is the variation on the consumption of that mineral. So the variation on the consumption, it's highly dependent on many factors like region, season of the year, and weather patterns. Further, we also have animal individual requirements, palatability of the mineral mix, and also the salt content of water. So it's evident that we need to better understand how these factors affect the mineral supplement intake, and also better understand the behavior of the animals related to the consumption of mineral supplements. So, therefore, the objective of this study was to describe the behavior of beef cattle related to the mineral supplement consumption, and to better understand the factors that contributed to the variation of intake of free-choice salt-based supplements. So, beginning with material and methods, we had 3 studies on the past year. They started in May and last till December. They were independently, so each one was done in a time of the year, and they were pretty similar on what we evaluated. So on the first experiment, we have preferred Brahmas and White Angus heifers, and we just evaluate the preference of those heifers during the day to go a mineral feeder. The same thing for experiment 2, but we had Brahma and Black Angus cows. And on experiment 3, we did something different. We tested the location of the mineral feeder, if the animals would have a preference when the mineral feeder was near to supplementing water, under the shade, or in the center of the pasture. So for now on, I will refer to these studies as experiment 1, 2, and 3. So to assess the visits of the cows or heifers to the mineral feeder, we developed a technology, the radio frequency identification, to accurately assess the visits to the equipment. So it's the reader, no, I don't know where I should point, but the reader is this device that is attached behind the mineral feeder. So each animal had its own tag, and every time the animal would go to the mineral feeder, the reader would record its visit. So about the readers, we would check the reader every day to make sure they were functionally correctly. The readers, I forgot to mention on the previous slide, but the readers were set to read the same ID every 3 minutes, but the readers were able to read this different ID in the same time. So if 2 referers would go to the mineral feeder at the same time, the reader was able to read the 2 tags. And we collected the readings every week, and then we would go through every single reading just to make sure the readings were consistent. And we also replaced the batteries twice a week just to make sure we would not lose any data. So from the readings, what we did when we collect the data from the reader, we would stratify the readings by period. So in a 24-hour day, we divide the day in 3 periods, morning, afternoon, night, and then we would, from the time, I would get an Excel spreadsheet, so I would know the time that cow went to the feeder, so I would give 1, 2, or 3 to know which period that visit was done. So now on animals, on experiment 1, we had 4 Brahman, 4 Bradford, and 4 White Angus heifers during a 47 days evaluation. Those heifers had access to only 1 mineral feeder. On the experiment 2, we had 15 Black Angus cows and 19 Brahma cows during 35 days, and they also had access to only 1 mineral feeder. So experiment 3 is a little bit different. We had 48 heifers, and they were divided in 3 groups, and each group had its own feeder, mineral feeder, and then the feeder would be moved within the pasture, within the group, every week. Okay, so the locations for experiment 3, every week we move the reader beginning with the center of the pasture. Then on the second week, we would move the reader under the shade. Then we move it close to the supplements and the water source. So each pasture had only one water source, so we would not have a confounding factor with multiple water trough. So we also assess mineral supplement intake by the disappearance rate of the mineral supplement. So every week we collected samples to evaluate the dry matter of that supplement and also to do the intake of that group. We would add new mineral every 2 weeks, or if the previous supplement was below 10 pounds. So in the statistical analysis, all data were analyzed using mixed procedure of SAS. The visits were evaluated as daily or weekly visit to the mineral feeder as an average by period and by breed. Visits were tested for breed, period, and the interaction, except on experiment 3 where we tested for location. And results are reported at last square means and separated using PDF. Significance was set at 0.05 and tendency at 0.10. So beginning with the results from the very first experiment. Let me just, so we're going to have 3 tables, one for each study. They were going to be very similar. So we're going to have a brief introduction on the tables. So in the very first column, we have breeds. Then for the 3 colors in the middle, we're going to have the periods, and then the average of visits. In this case, the daily visits. So for the first study, where we had the Bradford Brahmas in Ona White Angus, we can see that the Brahma cows tend to have a greater number of visits to the mineral feeder when we compare it to the other 2 breeds. Then when we looked at the morning period, there was like Brahma and Bradford heifers, they went more frequent to the mineral feeder when compared to the Ona White Angus cows. For the afternoon period, the Brahma heifers had the greatest number of visits when compared to the other 2 breeds. And for the night period, both Bradford and Ona White Angus heifers visits the feeder more than the Brahma heifers. Then when we look to the preference within a day for a period for a breed, we see that Bradfords prefer to go to the mineral feeder in the morning, while the Brahmas prefer to go during the afternoon. And it seems that the Ona White Angus has no preference for a specific period of the day. So, as I mentioned, we evaluate the mineral intake. And for this particular study, the heifers experienced a range of intake from 38 to 130 grams per head per day, and they have an average of 79 grams per day. So there was a huge fluctuation on the intake, and it was expected. As I mentioned in my introduction, that's the main problem when we have animals in such a system. So on study 2, we have the Black Angus and the Brahma cows. Those were gestating cows, and if we look to the number of visits, the Brahma cows had a way greater number of the visits when compared to the Black Angus cows. And we cannot compare it straight to the heifers, but here we are showing it as a weekly visits because they visit way less than the heifers would visit to the feeder. So it was more consistent to show as weekly visit. So there was no differences on the number of visits for the morning period. In the afternoon, Brahmas again went visit the feeder more than the Black Angus cows, and there was no difference for the night period. But it seems that Black Angus cows would go more often to the mineral feeder at the night period. So on the mineral intake, they have an average of 30 grams per head per day. They also had a fluctuation on the intake, but in this particular case, the cows never reached the specific amount, which was 50 grams per day. So on the last study, where we evaluated the location, we see that the Brahma cross and Ona White Angus heifers made more visits to the mineral feeder when compared to the other two breeds. Then, when we looked to the specific locations, there was no differences for when the mineral feeder was positioned in the center of the pasture, no difference when the mineral was positioned on the shade, and then there was so the Ona White Angus heifers visit more the mineral feeder when it was positioned on the close to the supplement and water when compared to the other breeds. Then the majority, when we look to specific breeds, most of them made their visits when the mineral feeder was near to the supplement and waters, but the Ona White Angus cows, they visited less when it was in the shade. So on their intake, they also have a lot of fluctuation on the intake, and again, those animals never reach the target amount for mineral consumption. So as just the principal outcomes for each study, so for experiment 1, we see that Ona White Angus heifers did not show a preference for a period of the day. Brahma's heifers visits more in the mineral feeder and seems to prefer the afternoon period, and Brahma heifers visited the mineral feeder more often during the morning period. So for the experiment 2, so Brahmas again made more visits when compared to Black Angus cows, and it seems that Black Angus cows prefer the period of night, and it's probably due affect cows by the heat of the day, so they try to avoid the heat of the day and they go visit the mineral feeder during the night. And then for experiment 3, we see that Brahmas and Ona White Angus heifers made more visits to the feeder compared to the other two breeds, and the visits seems to be greater when the mineral feeder is located close to the supplement and water. So, thank you.
Are there any questions?
Juliana, you mentioned that the time of the year was normally after results, and you said each experiment is a different time of the year. Can you please explain a little bit further?
So the question was, I mentioned that the experiments were done in different times of the year. Yes, they were, but they were mostly done during the fall and winter time. So as Dr. Arthington mentioned before, we had a decrease in intake during the winter, so I don't believe that would affect a lot. If we had done like during the summer and winter, we probably would see an effect of the season of the year.
Julie?
Juliana, is there any speculation why you think the cattle might have more visits throughout?
Good question. So the question was if there's any speculation on why Brahma cows go more to the mineral feeder. I'm trying to go to literature and see if I find anything, but so far, no lucky. But personally, I think they cope better with the heat of the day, and therefore they are more active. So they would spend more during the day. They would graze more. They would walk more. So that's the simple reason. And then compared to the Black Angus cows, they would rest during the day. They would stay in the shade and not go to the mineral feeder.
One thing we haven't been able to do yet, and she's part of Juliana's work right now, is just because they visit more doesn't mean they eat more. So we don't know. They may visit more and consume the same amount of mineral than the others. And she's working on that right now with an evaluation where we are separating the two.
Does the hydroxy minerals, does that be less soluble? Is it going to affect the absorption in the cow?
We've ran studies before looking at mineral status of the cows and calves and comparing source, and we don't really see any differences at all. The elements are highly soluble at lower pHs, and as soon as it passes into the GI tract, it becomes soluble. Yeah. Raul?
I have the same question. Do you think bronchos secrete more minerals out of their system through more sweat glands? I mean, I know they have the same amount of sweat glands in skin or surface area. Just secrete more minerals out. Maybe. I know bronchos no sweeter.
Okay, so the question was if the
Secrete more minerals.
yeah, if the animals could secrete more mineral through their sweat. It probably is true, but it also depends on the mineral, I guess, because not all of them could be secreted by sweat.
But I think that that's a very logical approach, because the craving, as I spoke about earlier, the craving to go to the mineral is salt related. And if they are excreting more sodium chloride, then they'll probably crave it more, just like people do if they're sweating more. Any other questions?
I have one for you, John. You mentioned that the preferential consumption is related to the different type of metals. You said that it goes down, and then it disappears during the wet week, but then it all of a sudden you observe a preferential again. How can you explain that?
The question is, why are we seeing variation in preferential intake related to precipitation in the week?
Or the change in the direction.
Okay, so I didn't show this slide, but remember that study was done over 18 weeks, and what I showed you was a summary and a pie chart of the average over that 18 weeks. But we had a week by treatment interaction that I did not show you. And some weeks there was no preferential intake. They ate the same amount of each of the minerals offered. Other weeks there was a large preference for the hydroxy formulated mineral. The reason for that, we hypothesize that the reason for that is that it's because during those wet weeks, the other two, the organic and sulfate, became leached. Now the metals are no longer in it to cause the aversion of intake. So they eat them all the same. They eat it and it doesn't give them a taste aversion.
At that point on, the metals continue to be gone. So why do?
Because every week we changed out the mineral, put fresh. So every week we would by disappearance rate, we would collect all the mineral out, weigh it, dry it, and measure dry matter intake, put fresh dry mineral in. Yeah. João.
Okay, I was just going to ask if you, there is any report in literature about the intake of each of those two sources when animals don't have the chance to select food.
Excellent question. So I didn't show that data, but that was the next experiment that we ran. So in this manuscript, there's 3 parts to it. There's these 2 parts, the laboratory leaching and the preference intake, and then there's the 3rd study. And in the 3rd study, we offered only one option. So randomly distributed either sulfate formulated mineral or hydroxychloride formulated mineral. When they don't have a choice, the calves eat the same amount, consume the same amount, and there was no difference in mineral status. Now when the cows were provided the same thing, they tended to consume more of the hydroxychloride formula, but not that much more. But they tended to consume a little more. Also, no difference in mineral status in the cows. So at least our first evidence shows that in salt-based minerals, even though they would prefer to consume the hydroxychloride provided it's there, they likely consumed to satisfy their salt requirement anyhow, and did not have a big difference. Okay. Well, thank you for your attention, and we appreciate you being here.